Now we are still on the applications of trigonometry, and in our last lessons we have dealt on sine rule and as well as cosine rule, where we have used the sine rule to evaluate the sides and also the angle, and the sine rule simply states that A divided by the angle of A is equals to length B divided by the angle of sine B, and is equals to C divided by the angle of C. And cosine rule works in such a way that we can find the length and also the angle, where C squared is equals to A squared plus B squared minus 2AB cos C. Now we want to move further into the application section as we deal with angle of elevation and depression. Yes, I'm sure you might have heard of it before, but then let's take it from the beginning. Angle of elevation. What does it mean? And what does angle of depression mean? The angle of depression can also be called the angle of dip, where some people just say depression. But let's leave it as it is. Now, the angle of elevation occurs when there is an angle formed between the horizontal line and the line of sight moving upwards. So we can say it's simply between the horizontal line and the line of sight. Okay, when it is looking upwards. However, the angle of depression is between the horizontal line and the line of sight when it is looking downward. So let's have a graphical representation of this so that we will have understanding. Now we have a tower here, and there's someone standing just at the base of the tower, and the person from this observer lens or his observer eyes is looking at the end of the tower upwards. Okay, tower, distance between the tower and the person. Then the person is looking at it at an angle theta. We'll call this angle the angle of elevation, because it is between the horizontal line and the line of sight, between the horizontal line and the line of sight looking upwards. Similarly, if we have the tower here and the person is lying down on the tower observing an object, okay, observing an object, we have the tower, the person lying down, and the person is observing an object, maybe with the binoculars or something, and is looking directly downwards to that object. Now there is an angle of depression. However, the angle of depression is between the horizontal line of the observer's eyes and the line of sight. So we can see the line of sight, and we can see this is the horizontal line, and this is the line of sight, and we call this alpha. So this alpha is called the angle of depression. Now you will notice something spectacular about these two diagrams, is that both of them always result to a right angle triangle. So I have a right angle triangle here and also a right angle triangle here, and in the right angle triangle we can apply the Pythagoras theorem, okay, where we say hypotenuse squared is equals to the opposite squared plus the adjacent squared. And we can also apply the SOHCAHTOA okay, where we know that sine is opposite divided by hypotenuse, cos is equals to adjacent divided by hypotenuse, and tan is opposite divided by the adjacent. So for establishing understanding, let's take two examples here. Let's begin with example number 1. Now, example number 1 says a person is standing 50 meters away from a tower and observes the top of the tower at an angle of elevation of 30 degrees. Find the height of the tower. Now, this is the tower with an height h. Now, the person is standing, okay? We have the person here, let's call it point P. Standing 50 meters away from the tower. So definitely it's coming from the base of the tower. We call this base of the tower B. And let's call this the top of the tower T. Now the angle of elevation, that means the angle between the horizontal and the line of sight looking upwards, just as we have here, is 30 degrees. So therefore we are saying that the line of sight looking upwards from point P, from the person observer length, to point T, the top of the tower, is 30 degrees. So in essence, we have a right angle triangle. So in the right angle triangle, we simply have the height, the hypotenuse, and the base. We have the base to be 50 meters, we have the height, and we have the angle 30 degrees. Now the question is, what is the height? Now, if we consider angle 30 degrees, we have the opposite to be h, we have opposites, and we also have the adjacent to be 50, and we have angle theta to be 30 degrees. So now, what relates opposite and adjacent alongside with theta together? Remember, this time around we'll be applying SOHCAHTOA. And in that case, we are going to be applying the TOA aspects, that's the tangent, because tan theta is equals to opposite divided by the adjacent. So in this case, tan 30 degrees is equals to the opposite, which is h, the adjacent, which is 50. So with this, we can evaluate the height of the theta of the tower. So if we cross multiply, we have that height is equals to 50 multiplied by tan 30 degrees. Tan 30 is an expression of 0.5774. And if we use our calculator for this, we'll have the height of the tower to be approximately 28.85 meters. So now we can see that the height of the tower is 28.85 meters. Let's take another example. This time it will be on angle of depression or angle of dip. From our clipboard, we have this. It says a lighthouse is 60 meters above sea level. We have a boat spotted at an angle of depression, emphasis on depression, of 20 degrees. We should find the horizontal distance of the boat from the base of the lighthouse. Now, let's show this in a diagram. We have the lighthouse, just as we see in movies. The lighthouse, let's call this point L, and a boat is being spotted. That means it's on the sea, and a boat is being spotted here. Let's call this point B. It's being spotted 60 meters above sea level. So therefore we are saying that the length, the height of the lighthouse is 60 meters. and the horizontal distance between the boat and the base of the lighthouse is unknown. That's what we are looking for. The horizontal distance between the base and the between the boat and the base of the lighthouse is unknown, which is what we are looking for. Okay, what's happening? Now the boat is spotted at an angle of depression of 20 degrees. So therefore there is a line of sight between the top of the lighthouse and the boat. So we are saying that the line of sight is coming downwards to the boat. However, it is an angle of depression. Now let's take a look at the angle of depression diagram here. Now the angle of depression is between the horizontal line, okay, and the line of sight looking downwards. Now the horizontal line and the line of sight looking downwards. Let's depict that here. So in that case, we'll have the horizontal line and the line of sight looking downwards, and the angle between them is 20 degrees. Now that is the angle of depression. Now we have the height of the lighthouse to be 60 meters, and we are asked to find the horizontal distance from the boat to the base of the lighthouse. Let's call this distance x. So let's simplify this in a simple diagram. We have a right angle triangle let's move to another point. We have a right angle triangle with a height of 60 with the base of x, and we are given that the angle of depression, that means this angle here, is equals to 20 degrees. So we have this angle to be 20 degrees. Now according to adjacent angles, definitely we are saying that this angle, because these two lines and this line are parallel, then this space will be 20 degrees. So with respect to that, we will have the result to give us a right angle triangle, a simple right angle triangle with an angle of 20 degrees, a height of 60 meters, and a base of x, and we are asked to find the base x. So we can see it's something similar to what we did previously. So with this, we can find the base of x. We have the opposites, we have the adjacent, and we have theta. What relates opposites and adjacents alongside theta together is simply tan theta is equals to opposite divided by adjacent. Now what we are looking for now is the adjacent, which is x. So I'm saying that tan 20 degrees is equals to the opposite, which is 60, the adjacent, which is x. So making x with a formula, x will be equals to 60 divided by tan 20 degrees. So making our substitution, we have 60 divided by 0.364. And using our calculator to simplify this, we'll have that the base, the horizontal distance of the boat is at 164.84 meters.